Good afternoon, students. In the yesterday's class, we discussed about how to write the electrode means half cell reaction, separately anode reaction and cathode reaction, complete cell reaction, and also calculated EMF. Okay. So to calculate the EMF of the particular cell, okay. So to calculate EMF of the particular cell, we have some equations. Okay, that is suggested by the scientist Nast. Okay, so Nast introduced an equation that tells about what is the calculation of electrode potential of individual ions, individual electrodes. How to calculate means I told you. So copper is plus 0.34 volt. How this 34 volt came? ನಮಗೆ ಇನ್ನು 0.34 ವೋಲ್ಟ್ ಅಂತ ನಾವು ಯಾವ ತರ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. Okay, so that is explained by what? By who? The Nast scientist gave some equation. Okay, by using that equation, we can calculate the EMF of the cell. Understand? So individual, so listen, zinc is there individually, copper is there. So zinc value is 0.76 volt and copper is 0.34 volt. Then we can easily calculate. How come we came to know copper alone is 0.34 without taking any reference electrode? ಅದಾಗ್ತಲ್ಲ ಕಾಪರ್ 0.34 ಅಷ್ಟೇ ಅಂತ ಯಾವ ತರ ಗೊತ್ತಾಯ್ತು? ಜಿಂಕ್ 0.17 ಮೈನಸ್ ಅಂತಾನೆ ನಮಗೆ ಯಾವ ತರ ಗೊತ್ತಾಗುತ್ತೆ? ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಒಂದು ರೆಫರೆನ್ಸ್ ಎಲೆಕ್ಟ್ರೋಡ್ ನ ತಗೊಳ್ತೀವಿ. ಓಕೆ, ಸೊ ದಟ್ ರೆಫರೆನ್ಸ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ SHE. ದಟ್ ಮೀನ್ಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ hydrogen electrode. Standard hydrogen electrode. So ನೀವು ನನ್ನ ಒಂದು ಲಿಸ್ಟ್ ಕೊಟ್ಟಿದ್ದಲ್ಲ ಸೆಟ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಇನರ್ಟ್ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಹೈಡ್ರೋಜನ್ ಗೆ ನೋಡಿ ಅಲ್ಲಿ 0 ಇದೆ. ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಇಸ್ 0. SHE ವ್ಯಾಲ್ಯೂ ಇನರ್ಟ್ ವ್ಯಾಲ್ಯೂ ನಾನು ಅದಕ್ಕೆ 0 ಕೊಟ್ಟಿದ್ದೀನಿ. ಯಾವುದಕ್ಕೆ? SHE ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್. Okay, so by taking this one as a reference, we can calculate them. And ಅದು ಯಾವ ತರ ಅಂದ್ರೆ ನೋಡಿ, ಫಸ್ಟ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ and cell reaction and EMF of the standard hydrogen electrode na first explain ಮಾಡಿ. So construction ಯಾವ ತರ ಇರುತ್ತೆ ಅಂದ್ರೆ, so listen, this is the electrolyte. Okay, so in this electrolyte, platinum electrode is placed. This is the platinum electrode. Okay, and this one is electrolyte, and that electrolyte must be an acid, means which consists of H plus ion, because we are talking about hydrogen electrode, standard hydrogen electrode. Okay, that means this electrolyte must consist of hydrogen atoms. Okay, so then what happens? This is connected to the external battery, and within this this is the arrangement. From here H2 gas is bubbled. So listen, here H plus ion concentration. You may take dilute HCl or dilute H2SO4, anything that must consist of what? H plus ion. HCl means H plus Cl minus. H2SO4 means 2H plus SO4 2 minus. Dilute acids we have to take as this electrolytes, and platinum electrode is here, and to that hydrogen gas is bubbled. Okay, this is the arrangement of SHE, standard hydrogen electrode. So ಏನಾಗುತ್ತೆ students, listen, now hydrogen ಇಲ್ಲಿ hydrogen gas H2 ಇದೆ, ಇಲ್ಲಿ H plus ಇದೆ, alone reaction ಆಗುತ್ತೆ. This platinum, so before ನಾನು ಹೇಳಿದೆ surface chemistry ನಲ್ಲಿ platinum is acts as a catalyst. So this catalyst give a surface for the absorption of the gaseous atoms. Hydrogen is a gaseous atom, it gets absorbed here. Listen, ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಸರ್ಫೇಸ್ ಇದೆ ಅಲ್ವಾ. ಸೊ ಇಲ್ಲಿ ಇನ್ಲೆಟ್ ಅಲ್ಲಿ ಬರೋ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಇಲ್ಲಿ ಬಬಲ್ ಆಗುತ್ತೆ. Means it is absorbed on the surface of this metal. ಅರ್ಥ ಆಗ್ತಿದೆನಾ? ಇಲ್ಲಿ H plus ions ಇದೆ ಅಲ್ವಾ. This H plus ions. So this H2 loses electrons, form H plus and 2 electrons and ions in this. ಇಲ್ಲಿಂದ ಬರೋದು H plus ion ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ H2. ಇಲ್ಲಿ H plus ಇರುತ್ತಲ್ವಾ, H plus and Cl minus. This H plus accepts an electron from H2. This is the reaction going to happen in this SHE. Same, there is no any other change. Only hydrogen gets converted into ion. At the same time, ion gets converted into hydrogen. Understood? So this reaction happens here. So students, that's why overall change. So anode reaction, cathode reaction, everything remains same. So that's why EMF of this SHE becomes 0 because only one ion, positive loss of ion, conversion of ion and the conversion of metal. Assume it's this one as a metal. So both the anode reaction and cathode reaction are same. There is no change in them. That's why the EMF of the cell is always remains 0. Understand? So by taking this one as an example, listen. How to write the cell reaction of this under electrode reaction if you want to represent. This is electrode representation. Electrode representation. So initially platinum is there. Next H2 is there. H2 converted into what? H plus ion. 3 concentrations are there. Anode or cathode, H2 and H plus ion. Understand? Here we want to write the pressure. As these are gases, this is 1 bar pressure. This is 1 molar concentration. This one is 1 molar. This H2 is 1 bar pressure. This is what? Electrode representation for SHE. Standard hydrogen electrode. Okay? So electrode reaction. What is the reaction happens there? Electrode reaction. What happens here? So H plus ion from this concentration accepts an electron form of H2. This is the reaction. So the inert of this is how much? 0. This is the electrode reaction. Here nothing is anode, nothing is cathode. Reaction is same, only one reaction is happening. So the reaction is H plus electron gives rise to half H2. This is the standard electrode reaction. So inert value for that is how much? 0. So by taking this SHE as a reference, then we can easily calculate EMF of the individual electrodes. Understand? How? Listen. Okay. SHE and copper you take. Okay? So students, SHE inert value is 0 and this copper inert value is 0.344. Okay? So we don't know which one is cathode, which one is anode. And at the same time, we don't know inert value of this copper. We don't know inert value of this copper. Just now it's simply written like this. So listen. Here, so how to calculate EMF of the cell means E cathode minus E anode. Okay, so we know only the EMF of SHE, how much it is? Inert is equal to 0. SHE we know, that is the standard hydrogen electrode, its EMF is 0. But copper we don't know. After finding out of the electrode experiment, okay, after setup of the copper electrode, and this one is taken as the reference electrode. This is also called as reference electrode. With this reference, we can calculate EMF of other elements. Okay, so listen, we can get completely E cell value is plus 0.34. Okay, so students, I told you, always this must be a positive value. That means what? This must be a greater value, this must be a least value. ಅರ್ಥ ಆಗ್ತದಲ್ವಾ? ಇದು ಜಾಸ್ತಿ ಇರಬೇಕು, ಇದು ಕಡಿಮೆ ಇರಬೇಕು. ಇಲ್ಲ ನೋಡಿ, ಈ ಸೆಲ್ ಅನ್ನೋದು ಎಷ್ಟು ಬಂತು? 0.34 ಬಂತು. ಓವರ್ ಆಲ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ವ್ಯಾಲ್ಯೂ ಎಂತಲ್ಲಿ EMF of the complete cell becomes arrangement. How it is? So listen. This is the two arrangement. Here two electrodes are there. So setup is made. Later I check which one is anode, which one is cathode. So after that completion of the cell, when they interconnected by the salt bridge and all, then they get what? This value 0.34. The EMF of the cell. Here potential meter is there like this, you know. They are interconnected. So here the value we got is 0.34 voltmeter. You know that? Okay. So from that we can easily came to know if E cell is 0.34 plus apply here plus 0.34 is equal to E cathode minus E anode is 0. Why? So it is plus value means this must be a least value. Least value is which one here? This one is He. That is 0. So that means anode is He, cathode is copper. So here we have to set He electrode. Okay, this is the reference electrode for He. And this is copper electrode. When they interconnected, they generate a EMF of 0.34 volt. So this is 0. The overall EMF is equal to EMF of the cell is equal to EMF of this electrode. Understand? So this is how we are going to calculate the EMF of the individual electrodes by taking this one as a reference electrode. ಅರ್ಥ ಆಗ್ತದಲ್ವಾ? ಸೊ ಇದು 0 ಇರುತ್ತೆ, ಅದು ಫೈನಲ್ ಇರುತ್ತೆ. ಅದರ ಬೇಸ್ ಮೇಲೆ ನಾವು ಇದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಅರ್ಥ ಆಗ್ತದೇನಾ? ಇವಾಗ ನೋಡಿ ಇದೇನ, ಇದು ಆನೋಡ್ ಆಯ್ತು, ಇದು ಕ್ಯಾಥೋಡ್ ಆಯ್ತು. ಓಕೆ, ಸೊ ಇದರ ಸೆಲ್ ರಿಯಾಕ್ಷನ್ ನ ನೀವು ಬರೀಬೇಕು, ಕಂಪ್ಲೀಟ್ ಸೆಲ್ ರಿಯಾಕ್ಷನ್. ಸೊ ಯಾವ ತರ ಬರೀತೀರಾ ಅಂದ್ರೆ ಸೊ ಇದನ್ನ ಫಸ್ಟ್ ಬರೀಬೇಕು. ಆನೋಡ್ ಫಸ್ಟ್ ಬರ್ತು, ನೆಕ್ಸ್ಟ್ ಕ್ಯಾಥೋಡ್ ಬರೀತೀರಲ್ವಾ? ಆನೋಡ್, ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್, ಕ್ಯಾಥೋಡ್. ಸೊ ಆನೋಡ್ ಯಾವುದು? ಇದು ಪ್ಲಾಟಿನಮ್ ಬಾರ್ H2 ಬಾರ್ H plus, here 1 bar, platinum bar H2, so that is 1 bar slash H plus, that is 1 more. Here salt bridge. This is He connected by salt bridge, and this one is cathode, metal ion bar metal. Okay, so here the EMF of the cell is equal to 0.34 volt, which is equal to the EMF of the copper electrode. Okay, next. ಈ ಜಾಗದಲ್ಲಿ ನೀವು SHE and zinc ಅನ್ನು ತಗೊಂಡ್ರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. SHE and zinc. Now calculate EMF. So E cell is equal to E cathode minus E anode. Okay. So then E cell become, after calculation, I told you same setup will be arranged. So like this, here two electrodes are taken. Among these two, one is SHE, one is zinc electrode. We don't know which one is SHE, which one is zinc electrode, but they are connected. Okay, and the solutions are interconnected with the salt bridge. Okay, now we get the EMF minus 0.76 volt. Here the EMF value we got is how much? Minus 0.76 volt. So E cell we got minus 0.76 volt from the experiment. Then we know the SHE inert value, how much it is? 0. So it is 0. We are getting -1. So then this must be 0. This must be that one. Are you getting? So minus value we are getting is this one is a 0 minus 1. Here we are getting 0.76 volt overall cell reaction. That E cell must be always positive. This is overall cell reaction. How much? 0.76 volt. Understand? Now we have to calculate E cell of this 0. Understand? Listen students, here E cell is how much? 0.76. That is equal to SHE minus E naught of SHE minus E naught of zinc. So minus of minus 0.76 means this is equal. So this is 0 is equal to minus E naught of Zn. Sorry. 0.76 is 0.76 is equal to 0 minus E naught of Zn. So E naught of Zn becomes minus 0.76. By taking the reference of this, we can easily calculate the individual electrode potentials. Andre idನ್ನ reference ಆಗಿ ತಗೋಬೇಕು. ಇವಾಗ ಏನು ಗೊತ್ತಾಯ್ತು ನಿಮಗೆ? ಇದು 0 ಇದೆ ಅಂದ್ರೆ Zn ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ಇದೆ. ಸೊ ಯಾವುದು ಜಾಸ್ತಿ ಇರುತ್ತೋ ಅದು ಕ್ಯಾಥೋಡ್ ಇರುತ್ತೆ, ಯಾವುದು ಕಡಿಮೆ ಇರುತ್ತೋ ಅದು ಆನೋಡ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಜಿಂಕ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಇರುತ್ತೆ. ಲೈಕ್ ಆನೋಡ್. And SHE is here. This is SHE, this is zinc, this is cathode, this is anode. So cell reactions are very good. Anode first, followed by cathode. Right? So anode first is metal bar metal ion. Correct? Double slash. Next, electrode reaction representation of the SHE. What it is? Sorry, aduna reversely baribeku. Metal ion followed by this. Correct? Illodi yav ತರ ಬರ್ದಿದ್ದೀರಾ? Cu plus 2 for Cu. Metal, metal ion, metal ion, metal. So here metal, metal ion. Next ion, metal. So H plus 1 molar. Super platinum. Adana reversely baribeku. Understand? So this is how to write or calculate EMF of the respective electrodes by taking SHE standard hydrogen electrode as a reference. So after finding out of this electrode potential, as I told you, the scientist must introduced equation which is helps us to identify and calculate the EMF of the cell by the effect experiments, by the concentration and all. Listen students. So by taking concentration, we can easily calculate the EMF of the cell. Initially, we have to write the cell representation: anode, salt bridge, cathode. So that means metal, metal ion. Okay. Here it's concentration, that's C1. M1 C1. Salt bridge, cathode, metal ion. M plus N, we don't know plus 2 or plus 3. Next, your concentration C2 for metal 2. Understand? Means we need to represent the concentration. Means zinc is there 0.01 molar, 0.02 molar, like that. The concentration should be mentioned in the representation of the cell. Later I will give. Okay. So students, based on this type of equation, a cell representation, the Nernst Institute introduced two set of equations. Okay, so I'll write here. First one is calculation. Nernst equation for electropotential. Okay. So listen always students, the concentration of metal is taken as 1. Pure metal taken as 1. Okay. Then the equation becomes E of plus n divided by m is equal to E naught m plus n over n minus 2.303 RT divided by nf log. Okay. So Azim, this is the standard equation. Now right here, this is the individual ion, this is the individual ion. R is the gas constant, T means temperature, F means Faraday, N means electron change. So this Mn plus 2 is the ion concentration of the respective ion. So apply this for Daniel cell. Daniel cell means zinc and copper. So initially, replace this Mn plus 2 m by 0. So listen, E Zn plus 2 bar Zn is equal to E naught. Here Zn plus 2 bar Zn minus 2.303 RT divided by N means here for the Daniel cell changes to plus 2 electron. Cu plus 2 accept 2. So N value become 2 and Faraday. Log 1 divided by concentration of Zn plus 2. Okay, next result. E Cu plus 2 bar Cu is equal to E naught Cu plus 2 bar Cu minus 2.303 RT divided by 2F log 1 divided by Cu plus 2 ion. So this one is equation 1, this is equation 2. So students listen, E of Zn plus 2, E cathode minus E anode, this is cathode, this is anode. So you have to do 2 minus 1. Subtract equation 1 from 2. Ilodi na direct barittane subtract ಮಾಡಲಿಕ್ಕೆ ಹೋಗಲ್ಲ. So E Cu plus 2 minus Cu, that is E cathode minus E anode means that become E cell. Here I will take initially listen E Cu plus 2 bar Cu minus E Zn plus 2 bar Zn. What this becomes? E cell. Okay, so I directly take E cell here. Similar, E naught Cu plus 2 bar Cu minus E naught Zn plus 2 bar Zn. Then that become, here I take E naught Cu plus 2 bar Cu minus E naught Zn plus 2 bar Zn. That become what? A cell. Understand? This become what? E naught cell. Okay, so students, minus. In the fourth case, common is what? 2.303 RT by 2F. Okay, so 2.303 RT divided by 2F here. So log of 1 divided by Cu plus 2 minus log of 1 divided by Zn plus 2. Correct? So then E cell is equal to E naught cell minus 2.303 RT divided by 2F. Then log m divided by n. Log m minus log n is log m by n. ಗೊತ್ತಿದೆಯಲ್ಲ? Log m minus log n, that is log m divided by n. So log is m values cu plus 2, n is zn plus 2. Okay, so ಇದನ್ನ ನೀವು again ಬರೆದರೆ E cell is equal to E naught cell minus 2.303 RT divided by 2F log, so this one divided by Cu plus 2 concentration, ಇದನ್ನ reverse ಮಾಡಿದ್ರೆ Zn plus 2 by 1 ಆಗುತ್ತೆ ಆಯ್ತಾ. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೀವು ಬರೆದಿದ್ರೆ Zn plus 2 by, so directly log of Zn plus 2 by Cu plus 2. Okay na? So Zn is an anode. In anode what happens? Oxidation. Cu plus 2 means cathode. At cathode what happens? Reduction. You know, Zn changes to Zn plus 2. Oxidation happen. Cu plus 2 changes to Cu. Reduction happen. This can be also written as E cell is equal to E naught. So initially you do. So students, if we calculate all this, take R is equal to 8.314 here and right. R value is 8.314. Temperature is 298 Kelvin. Faraday is 96,485 and N value is 2. So if you calculate all this, you will get the answer. N you don't calculate. So this N we just left. If you calculate this much, 2.313 into 8.314 into 298 divided by 96,485, you will get 0.091 as the answer. Divided by 2. So log of Zn plus 2 bar Cu plus 2. This is the equation for a Daniell cell. Understand? So students, this is by comparing with Daniell cell, I just derived this equation. But if you want to write, so listen, this is generally a E cell is equal to E naught cell minus 0.059. What is this 2? This 2 is N, change in electron. So the log of this Zn undergoes oxidation by reduction. This is the correct equation. Oxidation by reduction. Understand? Are you getting? So you don't need this much. You want only this equation and this equation. Understood? So just now listen here and just drop all these which is unnecessary, and I write only important. Okay, listen students, this is the first equation to calculate it. You may write 2.303 RT by NF as 0.0591 also. Okay, so I'll directly write the direct formula. So later you just substitute that. Okay, so E cell, this is what for individual electrode. Already I wrote. Next, last equation for EMF of cell. EMF of cell. Complete cell, not individual electrode. Complete cell is E cell is equal to E naught cell minus 2.303 RT divided by NF log oxidation by reduction. Okay, this is another formula. Next, students, is oxidation by reduction. This is always taken as equilibrium Kc. Okay, so then another equation. Last equation to calculate equilibrium constant. Equilibrium constant Kc, that is E cell is equal to E naught cell minus 2.303 RT by NF log Kc. Remember students, this is not completed at equilibrium, means always this E cell becomes 0. At equilibrium, that EMF of the cell, positive and negative, forward reaction and backward reaction, they are equal. Their potential is equal to what? 0. So that at equilibrium, E cell is equal to 0. That means substitute here, 0 is equal to E naught cell minus 2.303 RT divided by NF log Kc. So if you just rearrange that, you get 2.303 RT divided by NF log Kc. This is the equation actually, not this one. Because at equilibrium we are considering, means this E naught becomes 0. Okay, then this is the equation to calculate equilibrium constant Kc for the respective reaction. Understand? So here the equation becomes what? E naught cell is equal to 2.303 NF log Kc. That Kc means what? Oxidation by reduction, their concentration, or they may directly give the equilibrium constant value. Okay? So next, Gibbs equation to calculate EMF of a cell. So students, Gibbs equation means delta G is equal to minus NF in our cell. Delta G is equal to minus NF in our cell. Understand? You may also write this E naught cell is here, the value. According to that, delta G also equal to minus NF. Substitute this E naught value here, 2.303 by NF, sorry, RT by NF. Correct? Okay. 2.303 RT by NF log Kc. These two get cancelled. So delta G is equal to minus 2.303 RT log Kc. This is also one equation. So remember all these equations, students. In the tomorrow's class, we are going to study the problems based on these all problems. Understand? So this one is what? Last equation for electrode potential. Remember how to write this representation now? So metal, always its concentration is 1. Metal ion, concentration is C1. Metal ion, second means cathode, of metal ion of cathode, concentration is N2, C2, and this is metal. Always the concentration of metal is what? 1. Okay, so here what we have to do? At the concentration of M and Mn plus here you take concentration of this oxidized ion and the reduced ion. Oxidation by reduction. So there, for example, zinc and copper is there. we have to write concentration of zinc here, we have to write concentration of copper here. Instead of that, if I give this Kc value, equilibrium constant value, then this is the equation. For each and everything, equation is different. If delta G they given, then this is the equation. Relation between delta G and Kc, relation between delta G and EMF of a cell, relation between EMF of a cell and the equilibrium constant. Understand? So the most important thing is always the often we are asking question from only this formula. Often asking question. What it is? E cell is equal to E0 minus 2.303 RT by NF log oxidation by reduction. Understand? So students, this is all about what? That last equation and the SHE and its construction and its cell representation, their electrode reaction, okay, and how it is taken as a reference electrode to identify the EMF of the individual electrode. Andre alone zinc into alone copper to find out ಮಾಡಲಿಕ್ಕೆ not only zinc and copper, whatever it may be. Last class Ag ಬರ್ತದೆ ಏನಂತ plus 0.80 ಅಂತ. So even though the EMF of the cell becomes plus 0.80, that means what? That one is acts as a means SHE is 0, then the EMF of the cell is 0.80, then the Ag value is also equal to 0.80. ಅದರ SHE ನ 0 ಅಂತ ಗೊತ್ತಿರುತ್ತೆ, ಅದನ್ನ ರೆಫರೆನ್ಸ್ ಆಗಿ ತಗೊಂಡು ಬೇರೆ ಎಲ್ಲ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಇಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ಸ್ ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. And by using this last equation, we can easily calculate EMF of the cell with different concentrations. Now before radial cell ಹೇಳಿದಲ್ವಾ, both 1 molar ಅಂತ ಹೇಳಿದೆ correct? 1 molar zinc sulfate solution, 1 molar copper sulfate solution. Or before SHE ಗೂ ಹೇಳಿದೆ 1 molar ಇರಬೇಕು H+ concentration. Each and every electrolyte must be of same concentration. Same concentration ಇದ್ರೆ ಮಾತ್ರ ನಾವು ಬಿಫೋರ್ ಇರೋದನ್ನ ಅಪ್ಲೈ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಡಿಫರೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಸೊ ಇಲ್ಲಿ 0.01 ಇದೆ, ಇಲ್ಲಿ 0.03 ಇದೆ, ಡಿಫರೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಗುತ್ತೆ ತಾನೆ. ಸೊ ಅಂತ ಟೈಮಲ್ಲಿ ಈ ತರ ಈಕ್ವೇಷನ್. ವಾಟ್ ಇಸ್ ದ ನೀಡ್ ಆಫ್ ದ ಇಂಟ್ರೊಡಕ್ಷನ್ ಆಫ್ ದಿಸ್ ಈಕ್ವೇಷನ್ ಈಸ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ EMF ಆಫ್ ದ ಸೆಲ್ ಅಟ್ ಡಿಫರೆಂಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್. ಬೇರೆ ಬೇರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವ ತರ ಎಲೆಕ್ಟ್ರೋಡ್ ವೋಲ್ಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು. So this is all about the today's class. In the tomorrow's class, we will discuss with the problems regarding these formulas. Remember, 1 to 1.